All right, this is our final section of Chapter 2, and it's a little review of scientific notation for you. I know you've already experienced this in your science class and had to work with this quite a bit already. So this is when it came up in our class, so we're going to go ahead and review the rules of scientific notation. And scientific notation is just a shortened way of us to write numbers that are a little bit easier to deal with. And the rules are this first number in scientific notation, this number right here, that number, if I just say n is that number, has to be less than 10, but it also has to be greater than 1. So that number is somewhere between 1 and 10. That's very important for you to understand. If it's greater than 10, it's not in scientific notation, and if it's less than 1, it's not in scientific notation. Okay, and then this power of 10 is written as an exponent, and it just tells you how many places you have to move your decimal value in which direction to get back to the original number. So the rules for scientific notation for changing from scientific notation to standard form are this, okay? Multiplying by a positive power of 10 moves the decimal point to the right, okay, to the right. So then our second rule is that multiplying by a negative power of 10 moves the decimal point to the left. So those are rules you're going to need to remember, okay? Moves it to the right when it's positive, to the left when it's negative. And our third rule is the number of places that it moves is just whatever the exponent is. You can ignore whether it's positive or negative. That number tells you how many places. So in this case, it's negative. That tells us it's going to go left. How far left? 4 places. Okay? So let's take a look at how we do this. Write these numbers in standard form. 5.34 times 10 to the fourth. So first of all, the decimal point moves how many places? If you look at what the exponent is right here, that number is a 4. So that tells us that it's going to move 4 places. Is that number positive or negative? Well, that number is positive 4, right? So it's going to move to the right. Since it's a positive 4, it moves 4 places to the right. So to write our number in standard form, we're going to move this decimal place. Okay, we're going to start where it is, and we're going to go 4 places. 1, 2, and then we need 2 more spaces, right? So those will have to be added zeros, so we'll get 53,400. How about this one? 3.27 times 10 to the minus 3. Well, the decimal point moves how many places? This number is a 3, so it's going to move 3 places, but this time it's negative, so that tells us the direction. It will be left. Okay, positive moves right, negative moves left. So we're going to start where we're at, and we're going to go left 3 places. 1, 2, and I'm going to run out of room, but we're going to go 3. Okay, so our number will be, from where we started, 0.00327. Okay, so I've got kind of a fun thing here for you. Write each number in standard form. I want you to pause the video, write each of these 3 numbers in standard form, and I'll show you the solutions when you come back. All right, I hope you took a shot at those. 7.42 times 10 to the fifth. We're going to move 5 places. It's positive, so we're going to go to the right 5 places. So we get 742,000. Letter B, we're going to move 2 places. It's negative, so we go left. So we're going to go left from where we're at, and we get 0.061. And the last one, this one, we're going to move 2 places to the right, giving us 371.4. All right, so here are our rules to go from standard form to scientific notation. So here are your 3 steps. First thing you're going to do is move the decimal point to the right of the first non-zero digit. Okay, we want it to the right of the first non-zero, so the significant words for you here, it needs to be to the right of the first non-zero digit. Okay, and you'll see what that means when we do some examples. Second rule, count the number of places you moved the decimal point. That will give you your exponent. Find the power of 10. If the absolute value was between 0 and 1, then it's negative, otherwise it's positive. So in words, I think that's kind of confusing, but when you actually look at examples, it becomes a little bit easier. So first of all, let's look at this example. We want to write this standard form number in scientific notation. So what we want to do is we want to put our decimal point to the right of the first non-zero number. So our very first non-zero number is 3. So that's where we want our decimal point to end, is right there. So that's where we want to end up. So we don't have to include any zeros in the number. So we're going to have 3.725. And our exponent is just going to be however many places we moved. Okay? So it's going to be 3.725. Ignore this 1 million thing. I think it's easier just to go right to the exponent. So it's 3.725 times 10 to the 6th power because we moved 6 places. If you look at this, if we're at 3.725, our decimal point in our original number is at the end of the zeros. So how many places did we move? We actually moved 6 places, and that's why that is a 6. To determine whether this is positive or negative, since this number we started with is bigger than 1, this is a positive exponent. If it's less than 1, if you look at this number, this is a decimal number, and all decimal numbers like this are less than 1, this will have a negative exponent. Okay? So let's look at this one. What's the very first non-zero digit? And that would be the 3. So we want to end up with our number as 3.16. And how many places do we have to move it to get back to where we started from? We go 1, 2, 3, 4 places. So it's negative because this number is a number less than 1. It's positive when it's a number greater than 1. All right, here's 3 more for you to try on your own. Pause the video and we'll give you the answers when you come back. All right, hope you gave those a try. This one, okay, this one's a number bigger than 1, so we'll have a positive exponent. This one is less than 1, negative exponent. Letter F is less than 1, also a negative exponent. Our first non-zero digit is 1, so we want our decimal point to be right between the 1 and the 4. So we get 1.414. We don't have to include any of the zeros. How many decimal places did we actually move it? Well, if you look from right here, we went 1, 2, 3, 4, 5, 6, 7. So we went 7 decimal places. It's positive because this number is bigger than 1. This one, our first non-zero decimal is 8, so we want to go between the 8 and the 7. And we get 8.76 times 10 to the minus 3. That's how many decimal places we moved. It's negative because the number is less than 1. First non-zero digit is 1, so we're going to have 1.14 times 10 to the minus 1. We only had to move 1 place. This number is less than 1, so it's a negative 1. Here's an example from tourism. We have a table given to us by the Department of Commerce on how many dollars international visitors in the United States spent. And we want to order these from greatest to least. So one of the things you need to notice is that the exponents are different. We have different exponents. So we want to compare the ones that have the same exponents. Okay. So we want to go from greatest to least. So the biggest exponents we're going to compare first. So the Canada and the United Kingdom both have 10 to the 7th power, so we'll compare those two. And which one's bigger? Well, 1.06 is bigger than 1.03, right? So the United Kingdom will come first. They spent more than Canada. So 1.06 is bigger. So we'll go Canada and then the United Kingdom and then Canada. Okay. And then we can compare the other two on the inside there. So the other two countries are India and Mexico, 10 to the 6th powers. Which one's bigger? This one's bigger, right? So in that one, Mexico will be on top and India is on the bottom. So we have, in order from greatest to least, we would have the United Kingdom. Okay. Should probably write this down. We would have, I'm going to abbreviate this. United Kingdom spent the most, right? 1.06 times 10 to the 7th. And then Canada. And then after that we would have Mexico comes next. And lastly we would have India. So in order from greatest to least, we would have UK, Canada, Mexico, and India. So from that table that's given on the left, here's one for you to try. Order the cities according to the number of arrivals from least to greatest. Now our last table we went greatest to least, so you want to find the smallest ones first. So you're going to need to go ahead and find the ones with the smallest exponents. Notice they're different. This one has 10 to the 5th, and this one has 10 to the 5th, right? So compare these two first. Which one is smaller, 9.01 or 7.21? Well, it looks like the 7.21 is obviously smaller, so Boston is the least, followed by Metro DC, right? From there, you can compare the ones that have 10 to the 6th exponents. Okay, so we'll do that one in blue. So which one comes first? Which is the smallest of the ones left? So we've already done this one. We can cross that one off, and we've done this one. We can cross that one off. Just look at the number parts. Which number is the smallest? Okay, and it looks like Vegas is the smallest, so that's going to be number 3, right? Which one's the next biggest? It looks like San Francisco is the next one, 4th, and then Orlando is 5th, followed by LA and New York, right? So let's take a look. We should have them in that order. So we've got Vegas, then San Francisco, then Orlando, then LA, then New York. So Boston and Metro DC are smaller than those. So here is our answer. Hopefully we got those all right. Here's a little quiz for you. Go ahead and write these, the first 4 in standard form, the next 4 in scientific notation, and then lastly there is a table for you to go ahead and order from the least to the greatest. So pay attention to what you're doing here. This one is least to greatest. You want the smallest one first. And luckily for you, all the exponents are the same, so that one should be pretty straightforward. We'll see you next time.